Module 4, Graphs and Relations. Question 1. In an annual event, athletes compete against a vintage train in a 15-kilometer race. A road runs alongside the railway track for the entire length of the race. There are 3 rail crossings at points A, B, and C. Graph 1 below shows the height above sea level in meters along this road and the railway track. Part A. What is the difference in height in meters between the starting point of the race and rail crossing B? The height above sea level at the starting point is 120 meters, and the height above sea level at point B is 175 meters. Therefore, the difference is 175 minus 120, which is 55 meters. Part B. Between the start of the race and the finish, what length of road in kilometers is downhill? The downhill roads are BC and MN. Both BC and MN are 3 kilometers long. Therefore, the downhill roads add up to 6 kilometers. Part C. Consider the section of road between rail crossings A and B. Part I. Write a calculation that shows that the average slope of this section of road is 12.5. The coordinates of point A are 3 and 150, and the coordinates of point B are 5 and 175. So the average slope is 175 minus 150, all divided by 5 minus 3, and that equals 12.5. Part 2I. What is the unit in which this average slope of 12.5 is measured? The rise is calculated in meters because that's the height above sea level, and the run is calculated in kilometers, the distance from the start. Therefore, the average slope is measured in meters per kilometer. Question 2. On race day, Jasmine started the race at the same time as the train. The graph showing the time taken by Jasmine to complete the race is shown on graph 2 below. The train runs at a constant speed between the start and point B, and then also between point B and the finish. The table below shows the times at which the train is at the start, point B, and the finish of the race. Part A. On graph 2 above, add the graph that shows the train's time in this race. The coordinates of the point at the start are distance 0 and time 0. So the first point is at the origin. At point B, the coordinates are distance traveled 5 and time 35. And at the finish, the coordinates of the point are distance traveled 15 and time 60. And now we connect the points. Part B. The time taken by the train, t minutes, to travel d kilometers is given by the equations below. Part I. Using only the numbers given in the table on page 32, write a calculation that shows that A equals 2.5. A is the gradient of the second line segment. Therefore, A equals 60 minus 35 over 15 minus 5, that is equal to 2.5. Part 2I. Using A equals 2.5 and the numbers given in the table on page 32, write a calculation that shows that B equals 22.5. When D equals 15, T equals 60. We are now going to substitute these values into the second part of the equation, which is T equals 2.5D plus B. We are using this branch because D equals 15. And also notice that we substituted 2.5 for A. So we have 60 equals 2.5 times 15 plus B. Therefore, B equals 60 minus 37.5. That equals 22.5. The equation for Jasmine's expected race completion time is given below. Part C. In kilometers per hour, what is Jasmine's speed for the first 5 kilometers of the race? We know that speed equals distance over time. It took Jasmine 25 minutes to cover the first 5 kilometers of the race. So the speed for this part of the race is 5 divided by 25 in kilometers per minute. The answer must be in kilometers per hour, therefore we need to multiply by 60, and that gives us 12 kilometers per hour. Part D. How long after the start of the race does it take for the train to catch up to Jasmine? Write your answer in minutes and seconds. The train catches up to Jasmine at the point of intersection of the last two segments of both graphs. Therefore, we can write that 2.5d plus 22.5 equals 4d plus 5. We solve this equation for d, and that gives us 35/3. We need to calculate the time, therefore we are going to substitute this value into one of the equations. We are going to substitute in the second one just because it's easier. So 4 times 35/3 plus 5 equals 51.6667 minutes. That is 51 minutes plus 0.6667 times 60 seconds. That gives us 51 minutes and 40 seconds. Question 3. The organizing committee must budget for the race so that it does not make a loss. Let X be the cost of running the train on race day. Let Y be the cost of other race day operations. The graph below shows the shaded feasible region for inequalities that constrain the values of X and Y. The feasible region includes the 5 boundaries shown. 4 of the 5 inequalities that define the feasible region are given below. The coordinates of the 5 points shown on the graph are given in the table below. Part A. Inequality 5 completes the definition of the feasible region. Write down inequality 5. First of all, notice that point O does not have coordinates 0 and 0. The two lines that have positive gradients have equations y equals 5x and y equals 4x, and they should pass through the origin. There is a line with negative gradient, and that would be the equation x plus y equals 45,000 because y equals negative x plus 45,000. Then there is a vertical line that passes through J and M, that is x equals 8,000. And there is another vertical line that passes through K and L with x equals 10,000, which means that the missing inequality is x less than or equal to 10,000. An additional 5% of the cost of other race day operations is added as a cost for promotions. The total cost C of organizing and running the race is given by C equals X plus 1.05Y. Part B. Determine the minimum total cost. Let's rewrite the equation of the cost, making Y the subject. So 1.05Y equals negative X plus C. 1 divided by 1.05 equals 0.95. Therefore, y equals negative 0.95x plus 0.95c. We are going to use the sliding line method, so let's draw a line with gradient negative 0.95 somewhere on the graph. If we start moving this line, this is going to reach the feasible region the first time at point P. Point P is at the intersection between the lines with equation 4x and negative x plus 45,000. Therefore, x equals 9,000. If we substitute the x equals 9,000 into the equation y equals 4x, we end up with y equals 36,000. We are now going to substitute the point with coordinates 9,000 and 36,000 into the equation of the total cost. Therefore, C equals 9,000 plus 1.05 times 36,000 That is $46,800. Part C. The race organizing committee had a revenue of $75,000 from sponsorships and entry fees for the race. All costs will be paid from this revenue. Determine the minimum profit that the organizing committee can make from this race. The minimum profit equals revenue minus the maximum cost. The maximum cost occurs when x equals 10,000. Therefore, y equals 5 times 10,000 equals 50,000. We substitute the point with coordinates 10,000 and 50,000 into the equation of the total cost. So the maximum cost equals 10,000 plus 1.05 times 50,000, that is equal to 62,500, which means that the minimum profit equals 75,000 minus 62,500, and that is $12,500.